Welcome to The Explainer. Look around at literally any group of people, and you'll immediately notice something absolutely incredible: the massive, beautiful range of human skin colors. We're talking everything from very deep brown to extremely pale, and just about every shade you can imagine in between. But have you ever stopped to wonder why? Why did our biology come up with this massive spectrum? Well, today we're going to decode the fascinating, super complex, and honestly pretty surprising evolutionary story behind human skin color.
Okay, let's jump right into the core mystery here. To really get this, we've got to rewind all the way to the beginning. Here's a fact that's widely accepted by scientists, but still catches a lot of people off guard. Every single modern human alive today descends from ancestors who lived in Africa. And those ancient ancestors, they had dark skin. So if we all started out with dark pigmentation, how in the world did lighter skin ever enter the picture? Well, spoiler alert, it has absolutely nothing to do with intelligence or human worth. It is a brilliant, brilliant story of sheer biological survival.
So our species evolved under the intense, year-round, blazing sunlight of Africa. And that created a pretty major biological challenge for us, specifically UV, or ultraviolet radiation. Getting blasted with too much UV can severely damage your skin tissue. Enter melanin. This is the pigment that's responsible for a lot of our skin color. By absorbing and scattering that UV radiation, having higher levels of melanin basically acted as this incredibly effective built-in natural sunscreen. But as it turns out, protecting the skin from a really bad sunburn was just a tiny fraction of the story.
Now here is our first big evolutionary twist. The real superpower of dark skin was actually protecting something completely invisible to the naked eye: folate. Folate is an essential B vitamin, and it's absolutely crucial for cell division and, even more importantly, for healthy fetal development during pregnancy. And here's the kicker: intense UV radiation literally breaks down and destroys folate in the bloodstream. So having more melanin wasn't just some cosmetic shield. It was a vital adaptation to keep that folate safe, which basically ensured healthy pregnancies and the survival of the next generation.
But, humans were natural explorers. We didn't just stay put in one environment. Over thousands of years, populations migrated out of Africa, spreading into totally new regions of the world, much farther away from the equator. And this geographic shift, it changed absolutely everything. Moving way north or way south meant dealing with dramatically weaker sunlight, especially during those long freezing winters. The intense UV radiation that used to threaten their folate levels suddenly wasn't really a problem anymore. The whole evolutionary equation was flipped totally upside down.
With this much weaker sunlight, a brand new protagonist enters our story, and that is vitamin D. This nutrient is absolutely critical for absorbing calcium and building strong, healthy bones. But here's the catch, and it's a big one. Your skin only produces vitamin D when it's triggered by UV radiation from sunlight. Back in Africa, the strong sun meant there was plenty of UV to go around, even with dark skin blocking a lot of it. But in these low sunlight environments, that exact same dark skin suddenly became a huge disadvantage. The melanin shield was basically doing its job way too well, and it was blocking out the weak UV rays that were desperately needed to produce this vital vitamin.
So what we have here is this massive geographical tug-of-war playing out across thousands and thousands of years. On one side, in high UV environments near the equator, natural selection is strongly favoring high melanin to protect that precious folate. But on the flip side, in low UV environments further away, natural selection is favoring less melanin, just to allow enough UV radiation into the skin to actually make vitamin D. When you really think about it, human skin color is essentially this elegant, long-term evolutionary compromise. It's the body trying to perfectly balance these two absolutely critical biological needs.
Now, you might be sitting there wondering, okay, but was vitamin D really that big of a deal? Oh, absolutely. The stakes were literally life and death. Remember, we didn't have modern medicine or vitamin supplements back then. Severe vitamin D deficiency during childhood led to weak, improperly formed bones. This crippled basic mobility, which meant finding food and surviving, was incredibly tough. And it gets worse. In women, poor bone development could alter the shape of the pelvis, which made childbirth highly dangerous, if not fatal. Anything that threatens reproduction creates immense evolutionary pressure. These populations desperately needed a way to bump up their vitamin D.
So it all makes perfect sense, right? Humans pack up, move to low sunlight Europe, and boom, they immediately evolve lighter skin to soak up more vitamin D. Case closed. Well, actually, no, not quite. Modern research into ancient DNA has completely blown this expectation out of the water. The evidence actually shows that some early human populations living in Europe thousands of years ago retained relatively dark skin for a surprisingly long time.
Moving far away from the equator just did not automatically or immediately trigger pale skin. So what on earth was the missing puzzle piece?
That missing piece? It was their diet. Let's think about how this played out. Imagine an ancient population living in cloudy, low-sunlight Europe. At first, they're hunter-gatherers eating a massive amount of fish. And guess what? Fish naturally provides a ton of vitamin D. Because they were getting it from their food, they didn't need the sun to make it, so the evolutionary pressure to develop pale skin was actually pretty low. But then comes the agricultural revolution. Populations shifted away from fish and started eating grain-based diets which severely lacked natural vitamin D. Suddenly, they had to rely on that weak sunlight again, which forced a massive, rapid genetic shift toward lighter skin just to absorb those UV rays. It's wild. Diet and sunlight were completely intertwined.
I do want to pause for a second here just to clarify how our bodies actually respond to sunlight, because it happens at two totally different speeds. When we talk about this big color shift across populations, we're talking about long-term adaptation. That's evolution, changing average genetic traits across thousands and thousands of generations. On the other hand, you have short-term adaptation. Think about getting a summer tan or a spray of freckles after a beach day. That's just a temporary bump in melanin production within your own single lifetime. Basically, tanning is your individual body reacting in the moment, but evolution is your entire lineage adapting over millennia.
All right, let's hop over to another part of the world that makes this story even more incredible. Populations in East Asia also migrated to higher latitudes with lower sunlight, just like folks in Europe did. And yeah, they also developed lighter skin. But scientists discovered something amazing. They did it using completely different genetic pathways. This right here is a textbook example of convergent evolution. That's when different populations face the exact same environmental challenge and somehow independently arrive at a very similar biological outcome.
Think about it like this. Imagine you have two brilliant engineers, and you give them both the exact same problem. Build a machine that works perfectly in low sunlight. They both go off, do their thing, and build a successful machine. But when you open those machines up, the internal gears, the wiring, the blueprints, they're completely different designs. Evolution works the exact same way. You have a similar environmental pressure, you get a similar outward outcome, but the internal genetic route to get there is completely, totally different.
And just when we think we've got all the rules figured out, we hit what we call the Arctic mystery. If latitude and weak sunlight alone meant you get the palest skin, then traditional Arctic populations living in the extreme, dark, freezing north should logically have the lightest pigmentation on the planet. But they don't. Why is that? Well, once again, the answer is right there on their dinner plate. Their traditional diets are incredibly heavy in marine life, which is super rich in vitamin D from fish and marine mammals. Because their diets satisfied their biological needs, it actually took away the evolutionary pressure to develop ultra-pale skin.
Looking at South Asia also completely dismantles this whole latitude-only myth. Many populations there live under relatively strong sunlight, and yet you see this enormous, beautiful range of skin tones. Why? Because it's a really complex mix. You've got diverse ancestral populations arriving from totally different environments. Plus, local geography throws a massive wrench into any simple sunlight rule. Think about higher mountain elevations, think about shifting cloud covers, or localized microclimates. All these factors completely change how much UV radiation actually hits the skin. So even if two groups are at the exact same latitude, the evolutionary pressures on them can be vastly different.
Now, before we wrap this up, we need to emphatically clarify something incredibly important. What this entire sweeping evolutionary journey shows us is that human skin color is purely 100% a visible environmental adaptation. Full stop. It is a biological response to geography, diet, and sunlight. It does not indicate intelligence, it does not indicate ability, and it absolutely does not indicate biological superiority of one population over another. Pigmentation is quite literally just our biology's clever way of keeping us alive and healthy under different skies.
So, bringing it all together, skin color isn't just some simple evolutionary switch that gets flipped on and off. It is this complex, highly interactive biological record. It's the result of thousands of generations of interaction between sunlight levels, UV radiation, nutrition, incredibly diverse migration histories, physical geography like elevation and clouds, completely different genetic pathways through convergent evolution, and potentially even social preferences down the line. It's this intricate, dynamic, global history written right on the surface of our skin.
So the next time you see the incredible diversity of human skin around you, remember, you're not just looking at colors, you are looking at a living, breathing map of our ancestors' global journeys. Which leaves us with this final kind of provocative thought to chew on. If something as obvious and seemingly permanent as human skin color can change so dramatically just due to migration, environment, and diet, what other characteristics of ours are still changing right now, quietly, generation after generation? Evolution isn't just a finished chapter in a history book. It is actively happening all around us, right now. Thanks so much for joining me on this explainer, and keep questioning the world around you.